Hello students, in this earlier presentation we have learnt about what are transition elements and one of the most important property of the transition element, that is variable oxidation state and its stability. In this presentation we will learn about the color properties of transition elements. Color properties. If you observe, most of the transition elements in their solid state or in the ionic state or in the solution state, they are found to be colored in nature. Then why these transition elements are colored? This is due to the presence of unpaired electrons or incompletely filled d orbitals. If you observe that when a visible light falls on the colored substance, then this colored substance will absorb this visible radiation. Then what happens when a visible radiation it is absorbed? Once the radiation it is absorbed by the substance, the electron which is present in the lower energy d orbital, it will be excited to the higher energy d orbital, and the energy of this excitation corresponds to the frequency of the light absorbed. This is the pictorial representation of excitation of electron from lower energy orbital to the higher energy orbital. If you consider, this is the electronic arrangement in any transition element, then what happens if any visible light falls on that particular transition element, then one of the electron will absorb this radiation and the electron will be excited from lower energy level into the higher energy level. And this energy of this particular color, it is just right, or nothing but this yellow color will be sufficient for this particular electronic excitation. If you observe the nature of a color of absorbed and transmitted, the transmitted color is a complementary color of the absorbed light. The color observed corresponds to the complementary color of the light absorbed. Generally, we will see the complementary color or which will be reflected as the color of the substance. For example, if you consider the hydrated copper 2, it absorbs the radiation corresponding to the red light, but it transmits blue. Nothing but if you see any copper complex in your laboratories, you will be generally seeing copper complex as blue in color. This is the table of 3D transition elements. These are the different elements in their different oxidation state, and this is the configuration, and these are the colors shown by these particular transition elements. If you see in this particular table, you can see clearly if any element in its particular oxidation state has no unpaired electrons, it is found to be colorless. Scandium in +3 oxidation state, it doesn't have any unpaired electrons, therefore it is colorless. Likewise, titanium in +4 oxidation state, it is colorless. And again, if you see zinc in +2 oxidation state, where you have a 3D tin, a completely filled configuration, no unpaired electrons, therefore found to be colorless. Now, we will know about one more property of transition elements, and which is one of the most important property of industrial importance. It is catalytic properties. We will know about the catalytic properties. Before knowing about the catalytic properties shown by the transition elements, we will know first of all about what is a catalyst. Catalyst is again a chemical compound which will be generally added to any reactions which will be increasing the rate of a reaction or rate of formation of products without participation or involving any chemical reaction, or the catalyst will decreases the activation energy of any reaction. If you observe the most transition elements and their compounds, they will act as catalyst or they will show catalytic properties. So many reactions which are catalyzed by these transition elements are having a good industrial importance. The most common transition elements which are acting as a catalyst, example iron, platinum, nickel, and also one of the compound V2O5, that is vanadium pentoxide. Now we will know about how this particular transition elements are employed in any industry or what is the use. Iron in combination with molybdenum, it is used in the manufacture of ammonia in the laboratory. Vanadium pentoxide, it is generally used in the manufacture of sulfuric acid, that is H2SO4, by one of the famous process, that is contact process. Nickel it is used for hydrogenation of oils. Manganese oxide, it is used in the decomposition of hydrogen peroxide. Then why this transition metals shows catalytic activity? The catalytic activity of transition elements, it is again due to the presence of vacant n-1d orbitals, and the transition element metals or transition metal atoms which are acting as a catalyst will accept the electrons from the reacting molecules, and thus the reactants get absorbed on the surface of the catalyst. Then once they are absorbed, what happens? There will be a change in the oxidation state of metals which will provide a low energy path, which is a very important criteria for a reaction to cross the energy barrier. For example, if you take the vanadium pentoxide, which is used in the manufacture of sulfur trioxide, it is reduced from +5 to +4 oxidation state due to the formation of vanadium tetroxide, that is V2O4. This is the reaction. Now for example, if you take the manufacture of sulfur trioxide, we will have a starting material of SO2, that is sulfur dioxide. When sulfur dioxide, it was reacted with vanadium pentoxide, then what happens? The oxidation state of vanadium, it will be changed from +5 to +4, and we will see the formation of vanadium tetroxide, that is V2O4, along with the formation of our desired compound, that is sulfur